Good morning, good afternoon, or good evening, depending on where you are. And welcome to the Broadcast Electronics LNOS Group webinar on the new BESTXe3 and focusing on design innovation. I'm Chuck Kelly, your host, and I'm delighted to be joined today by an old friend. When I say old friend, we've known each other for more than 30 years. We started at Broadcast Electronics both in 1988, and I took a little hiatus in the middle, but I'm back. And uh, and Stuart stayed there and had increasing roles the whole time. Welcome, Stu.
Well, thank you, Chuck. Glad to be here.
And Stuart, aside from being director of operations at Broadcast Electronics, also was pretty much the chief designer or the football coach, if you will, in the design of the STX E3. And so the things we're going to talk about today, we're going to go through a little brief history of BEFM transmitters, just in case you think we're newbies. We're going to talk about what is the STX E3. We're going to take a look inside, talk about its digital readiness, talk about, we'll actually go through an on-air demonstration. I always enjoy those. And Stu's going to walk us through the menus of the STX E3 user interface. And then we're going to take your questions. And you'll notice that in the GoToWebinar application, you have a place you can ask questions by typing them in anytime you want during the entire presentation. And near the end, we will do our best to answer all questions. If we can't possibly answer them all, we will answer them by email following the webinar. In any case, remember that watching this webinar qualifies for a half a credit towards SB certification under Category 1. So we have a tradition now of asking $1 million question. And Stu, I got to ask you, why another FM transmitter? Why 3 kilowatts? Why would we do that?
Well, Chuck, we already had a 3 kilowatt transmitter in the STX LP Gen 2 3 kilowatt, but that was it had 3 separate units plus a combiner, so it was kind of large. So we wanted to provide a compact transmitter. Now we noticed out on the market there are 3.5. Well, we found that there was a sweet spot somewhere where somebody says, I want something a little bit more than a 2.5 kilowatt, and I don't need all the way up to a 3.5. So we thought, well, you know what? If we do a 3 kilowatt, we'll be right in that sweet spot. We'll be able to catch those people that are looking for 2,800 watts or something of that nature. So that's why we decided to design this 3 kilowatt transmitter.
Makes sense. Okay, very good. Thank you. In terms of a brief history of broadcast electronics FM transmitters, 44 years ago, BE began developing a new series of FM transmitters, which were based on a unique folded half-wave cavity, as well as a new exciter design, the FX30. And that FX30 offered signal-to-noise performance at least 10 dB better than the other companies at that time. And eventually, a few years later, other companies' exciters caught up. But at the same NAB show, and I was there, and it was an exciting time. You were probably there as well, Stu. BE introduced the FX50 exciter, which beat the competition's signal to noise by a further 10 dB. And later, BE introduced one of the first direct-to-channel FM exciters in the world, the FXi60, and has developed a full line of solid-state FM transmitters. And almost 20 years ago, BE was the leading innovator in HD radio technology with the first commercial XGen card and the first multicasting installation in the world. So pretty exciting history of the organization, and the innovation has not stopped. And today we're talking about the STX E3. First question for you, Stu, what's the E stand for?
It's a good question. I usually like to think of this E is having to be that everything is embedded into this unit. You don't need an external exciter. You don't need an external supply. Everything that you would need to broadcast is basically already in the unit. All your control, all your SNMP capability, everything is already embedded into it. The actual E is kind of still a line from our STXe exciter series. We wanted to differentiate the difference between the STX LP 3 kilowatt and the STX E3 that we are releasing here.
Sure. So in this particular case, we have a fully digital ready, digital direct-to-channel exciter built right into the transmitter. So it's all embedded into the transmitter.
That is correct.
Okay, and this joins the complete STX family, which goes from 60 watts to 20 kilowatts.
That is correct.
And it's new. So when are these shipping?
These will probably be my next manufacturing shipment for the next run. Will probably be shipping in beginning of September. I suspect we'll be able. There's been some slight delays in me trying to find some supply chain differences with this coronavirus going on. So
These are trying times.
that has kind of delayed certain paths of certain things. So, we had hoped to be shipping several of them before now, at least the first batch, but those delays have kind of slowed us down a little bit. So we've been looking and hunting and not sitting. Well, we'll wait for those other places to open.
Sure.
So we've been actively finding different paths because one thing we've learned from this is we should have multiple supply chains that we can pull equipment from, so we can constantly keep stuff moving. So.
Yep. So one thing I see on this screen that's interesting is the 4 knurled knobs, what I would call thumb screws on the front.
Mm-hmm.
And what does that do?
Basically, those thumb screws are removable. This will allow you to have access without using any kind of tools to remove the front panel. So the front panel and the handles will remove. The transmitter will remain operational. This will give you access again to the fans and to the PA power supplies. So you could actually change these PA power supplies from the front of the unit. You could actually change the fans from the unit. You don't have to go completely off the air. You could actually go and reduce power, change out a power supply if you needed to, or change out a fan.
Obviously, if you have a power supply pulled out, you're not at full power.
Right. If you have a power supply pulled out, you're actually going to have to go down to half power, because just the current capability of that power supply is just going to say, I can't do this, and it's going to protect itself by shutting down. But you could go to a preset power mode, which we'll talk about later in the transmitter, which allow you to duct power down to maybe a kilowatt or so and change out a supply. But chances are you probably are already at a lower supply if one of those power supplies should go out. However, these power supplies have been very reliable for us, and that's why we decided to use them. We've used these power supplies a lot in our 10 kilowatt, our STX 10 kilowatt and 20 kilowatt, and have been very successful. Have many installations throughout the world, many installations in India, in the US, and I have one failure of the power supply that I'm aware of.
Wow.
In probably 5, 6, 7 years, however long we've had this out.
That's cool. Now, one of the things that's interesting is that front panel we pulled off with those 4 thumb screws has the air filter built into it. So you can take that air filter and replace it or wash it and reuse it. But it also means that only filtered air gets to the heat sinks, the fans, to the power supplies.
Right. There is a reusable, washable air filter that goes right in front of this the fan assembly that you see there. There's plexiglass that holds that fan assembly in there. So at this point, I still don't need any tools to replace anything. So that air filter will filter out any kind of dirt or debris that can get into the transmitter, which is very important just to keep dust out, because after a while, the dust and heat really are what ends up damaging components more than anything.
Sure. Makes sense. Okay, well, let's keep on moving here. So this is what happens when you take the top panel of the STXe3 off. Describe what we're seeing here.
Basically, what you're looking at on your right-hand side of the screen is the back of the transmitter. And what we have there is our CPE board that we currently use in all of our STX line of.
Now that CPE board is the exciter, the digital direct-to-channel exciter, and the controller all integrated on one card.
Correct.
Okay.
It's controller, processor and exciter, basically, is what it is.
And web server for that matter.
Yes, and web server. It has SNMP3 capability as well as IP capability. So there are many things that can be done um, with this CPE. Now that's why we decided to use that in this design. Is we had something that already worked well. We'll continue to use that.
Sure.
Below that board, what you find is just a +5, +12, -12 volt power supply, and that pretty much just drives the control, the exciter, PA. The CPE provides about 100 milliwatts of output power. So if you combine that power supply with the CPE, and there's 4 wires that go up to the LCD front panel display, in just those 3 items there, you have a 100 milliwatt transmitter, basically.
Yeah, pretty capable. And there's a little card there in the lower left. What's that one?
The little card on the lower left is a DC to DC converter. Basically, it's going to convert your PA voltage to run the fans. So basically, all that does is it'll take the 18 to 52 volts coming out of the PA and convert it to the 12 volts to run the fans. So when the transmitter is in standby, basically the fans are off. We have, it's quiet.
Sure.
So to speak.
Sure.
The supply in the middle is a 24 volt for the driver supply. And we got plenty of space to put other accessories that we are probably not going to discuss here today, but we left plenty of room in this, and that's part of the design on this, was to design it to separate out different the switching supplies from a lot of the RF, and to do it in a way that makes sense as far as the chassis goes, and ease of assembly. So what you're looking at, like I say, is with the top cover off.
Right. So what you're saying, as I read you, is that, for instance, things that you may want to add to this device in the future that have to do with, say, for instance, digital radio, wink, wink, nudge, nudge, could be accommodated in this part of the chassis, and it's completely separated from the higher power side that's got all the magnetic flux fields and the RF and all that sort of thing that could potentially cause issues for small signal components in the future, and this completely solves that problem.
Yes, this is absolutely correct, and because the heat sink basically is underneath this panel is a heat sink, and so the fins are actually mounted up. So you actually have a lot more space between that and the RF boards and the RF ground plane there. So the isolation there was thought to help us to provide more stable place to put things in the future, like you had indicated with HD components.
Or DRM plus, for that matter.
Correct.
Who knows? All right, so let's talk about the direct-to-channel digital exciter. It's got incredible audio performance. There's multiple audio inputs with auto failover. The RDS generator is built in, and it does both static and dynamic. How do you feed the dynamic into it?
Basically, it's just assigning an IP. You just set it to a port. You send the dynamic to a port of the IP address, and you could send that information. The static you actually program in there statically. We'll discuss that later, but we do actually have in my setup, I have a TRE machine here that they had set up, so we will see it sending some dynamic information to the unit.
And you can build up an SFN with these units as well. It does have the micro adjust delay built in. I remember when Broadcast Electronics was a pioneer in SFNs, we used to have to source a micro adjust delay from Germany, and I remember it was like $7,000 each.
Yeah, they
we just built it in.
Yeah, they were quite expensive. The micro adjust delay will allow you to fine tune in and delay. So it's great for single frequency networking of transmitters. If say something just not quite right with the audio, you could adjust that up and down easily.
And this works with AES over MPX and baseband 192. which are really kind of cool. I mean,
Yeah.
those technologies, in my view, now that we have digital exciters and digital audio processors, just make more sense than anything, and they really do make a difference in the on-air signal.
Yeah. It's a lot night and day on just signal. The static is gone and
Yep,
it's clean.
yep. And then it's compatible with both HD radio and DRM plus, and it's got a built-in FSK ID for translators,
That's correct.
and you can set it
Um,
up for N+1.
exactly. We try to include a lot of things in there, just as a default, no extras, as far as no extra cost for these capabilities. We'll just, hey, let's just include these. If somebody
Yep,
needs them, they're there. They don't
makes
have to pay anything to turn them on. They could turn them off if they're not using them, but hey, we're going to make them available to the customer.
makes complete sense. Okay, the driver interface and splitter. Describe what we've got going on here.
Okay, basically what you're looking at is kind of a sideways view of the front of the transmitter. If you look to your right-hand side, this is actually the front of the transmitter. So if you pop the top off or actually
Bottom
pop the
off in this
bottom
case.
cover
Yeah,
of
yeah.
the unit, so you can actually flip it over, and hey, it'll run
Either
right
way.
side up or upside down. It
Yep.
doesn't care. It doesn't care. What you're looking at on the right-hand side there is our interface board and um, a driver.
Mm-hmm.
So what we've done with that interface board and driver, the driver is a 100-watt driver. We don't really need a 100-watt drive to drive the 4 pallets. We only need about 5 watts to drive each of the 4 pallets
Right.
that are in there. And we'll talk about it. It basically is an in-phase splitter
Mm-hmm.
that splits to those 4 pallets. We'll talk about that. We kind of see that on the other side of that wall. Again,
Yep.
we're separating different sections via walls so that we keep the interference down in between sections.
Sure.
The amplifier, or the linear amplifier that we chose a 100-watt amplifier, even though we don't need anything like that for the capability of being able to do DRM plus and HD. Basically, what really causes a problem when you do HD is running into the P1 dB, which is basically where the amplifier becomes nonlinear again.
Mm-hmm.
So in order to overcome that, that's why we have such a high power device in there for a driver when we're not even using that much power. We're using approximately a quarter of that power, but we got to have that headroom in order to be able to do to set it up for HD. So, we could have just, hey, let's use something less, but then that would make the device only FM only and not HD capable. But when
Sure.
we have everything else there lined up for that, it just makes sense to let's make it HD capable.
There's a lot of RF shields that I see here. I understand the reason for that, to keep the high power signals away from the low power signals and small signals. But are those just easy to pull off, or are they soldered in place and a bear?
The covers are easy to pop off.
Okay.
They got fences around them. You can pop them off. Basically, what we have there is we're taking the RF in from the CPE, and that feeds into just a couple pre-driver amplifiers. So each amplification stage, basically, we're kind of covering that so it gets less interference. If you follow the device around, there's a long rectangular tube or long rectangular can in there. That's just an extra filtering that we do, some pre-filtering before we end up sending it onto the splitter
Right.
to split it out. So any
Why
harmonics or anything
amplify harmonics, right?
right, any harmonics that we've created along the way, we want to make sure we get rid of those, because it's just wasted energy
Sure.
when you have an amplifier that's creating all these harmonics that are not needed.
Fair enough. Moving on here. Let's see here. There's the PA palette. We're using the BLF 188XR, which is really the latest device in the market.
Right. Right. This is the same device that we use in our STX-10 as well,
Mm-hmm.
for the pallets there. Um, we want to make sure that we were able to get basically a 1 kilowatt pallet capable out. So we got 4 of these pallets in the unit. It's configurable for class F and class AB. So basically we would just change the biasing for AB operation when we're doing DRM or
Sure.
HD. Only the filtered air cools the PA. There's a little bit of filtered air going across the top of the components just to keep them cooler.
Sure.
Transmitter actually runs ice cold. It's
Mm-hmm.
you could have it running for days and days and days, and it's ice cold. You'd swear it was off, but
Mm-hmm.
just doesn't generate a lot of heat.
Yep.
These are totally broadband, so there's no adjustment, so you can go from one end of the band to the other. And we designed the PAs to have plenty of headroom. Like I said, we 1 kilowatt modules to have plenty of headroom so that we can get that out,
Right.
get the power out of it without having any issues with that. The board you see in the foreground is basically we'll have monitor also temperature and currents, but it sets up our biasing for the device. And what's not shown there is at center of the bottom of that picture is basically where the splitter feeds into each device.
Right. Now, you mentioned Class F as if it was the most natural thing in the world, but gosh, most broadcast engineers know Class C for FM, and Class AB for digital radio. But what's this Class F thing?
Basically, kind of what Class F does is Class F gives you a little bit more efficiency, boosts the efficiency, by using the resonators to resonate harmonics, and tries to shape the output into more of a square wave to give you more power out. One of the things there's the overall efficiency of the unit may not, we don't get a lot of the overall efficiency because that does consume a little bit of energy to do that, but it gives us a cooler running PA.
Yeah, I would think so.
Gives us cooler running PA and longer life, basically,
Yeah.
expectancy of the PA.
You can
So,
see in this graphic at the top that classes D through T, which F would fall into, is substantially better in terms of efficiency, which, if you think about that upside down, means that it's going to dissipate a whole lot less heat than an amplifier in Class C, which is what virtually everybody else does for PAs in FM use. And the device is a BLF188XR, as mentioned, the most recent and current device on the market. It includes protection against overloads. Yeah, and it includes, it's very rugged, it's high efficiency, has excellent thermal stability, and it's designed from HF to 600 megahertz.
yeah.
Okay, so let's talk about the combiner here.
Okay, the combiner is basically a 4-port modified Wilkinson. The due to the linear layout of that, we left the end nodes off. This is a very similar combiner that is in a lot of the Elanos products. It's a little bit different than our 3dB combiner that's in the 10 kilowatt transmitter. 10 kilowatt transmitter module was actually kind of the idea or the design behind this whole transmitter is, hey, if we could change the interface and get a better efficiency combiner, we could actually make a pretty decent product out of this. And so that's kind of where that came from, and that design. So using Wilkinson was what's much better than the 2-stage hybrid combiner that we were using in the 10 kilowatt module.
And because it's strip line, all of the components are printed onto the board, and therefore the stability of it, the accuracy of it, the robustness of it is very high.
Right, it would be very consistent from unit to unit, and there's really nothing to go wrong with it. I mean,
sure,
there's not gonna be a component to wear out.
I'm thinking here as I look at this that these big areas of foil are capacitors, and these other parts here are largely inductors.
That is correct. That is
Mhm.
correct. Basically, what we've done is we've designed this combiner and have tuned it for optimum across the band, and so that's why we have certain capacitor pads designed in there. Some of the earlier prototypes actually would have copper soldered in to certain
Sure.
places to
Yeah.
optimize that design.
Okay. And then we've got the low pass filter and directional coupler. And typically those aren't so interesting, but we've actually gone a long way. I mean, this 10 element low pass filter is more aggressive than a lot of companies use, and it's designed to reduce the 800 megahertz cellular interference that some broadcasters are running into, and it's totally shielded.
Right, right. This low pass filter basically was designed out of the STX-10. We kind of made improvements to that low pass filter and rounded some of the edges just from some of the information we have in that. In the 10, it's a little bit different. We have multiple stages that are combined that are coming back through this low pass filter. So we ended up learning a lot from those and redesigned a better low pass filter. And then going forward on the low pass filter, this is a filter that's actually replacing that filter in the field as we continue on. We're just not going to build the older filter. This will phase right into
Sure.
that new filter. So
Okay.
uh, constant improvement. I mean, that's one thing that BE basically doesn't do is we don't deliver a product and go, there it is. Well, good luck with it.
Yep.
There's always constant improvement. We're always have software improvements that we get. We get feedback from customers. We find that there's something that we can do. We'll do a deviation. We'll send out a field kit. There's always a constant improvement with it. With everything that we end up doing is we don't just rest on it and go, well, that's what you bought. That's what you get. Now, what you buy when you buy a BE product is you get a company that'll stand behind you and say, we got your back.
Now, there is no truth to the rumor that there are some improvements in the pipeline for cart machines, is there?
No, no.
Okay. And then
Nope.
down below
No new pinch roller, no new pinch rollers or cart decks or anything else that I am aware of.
what's sad, my friend, is that half of the people that are sitting down and watching this webinar right now may not even know what a pinch roller is, but you and I do. Okay, so let's talk about the directional coupler. The
Yeah, the
figure of
direct.
merit for a directional coupler is the directivity, and these have been tested for better than 40 dB directivity, which means you've got
Yeah,
accuracy in your forward and reflective samples.
yeah. Directivity has a direct correlation to how well you can read reflected power. If you have poor
Mhm.
directivity, your reflected power could be anywhere.
Right.
It could be reading real low when you actually have high reflected power, or it could be reading real high when you have little reflected power. So directivity is probably one of the most important things in there. 40 dB is excellent. We actually have some couplers that we've designed that have 45 dB. When you start approaching that, you start approaching instrument grade type couplers. So for instance, the STX 20 kilowatt has a very high directivity coupler in a forward and reflected. It's a very interesting design on that.
Hmm.
But yeah, good directivity. This particular coupler, it's broadbanded. It's already flattened out for that, so we don't have to do any calculations of curves or anything
Hmm.
for frequency. This coupler has 3 actual samples off of it. It's got the sample for giving a RF output sample of 50 dB. That's at the top of this picture.
Hmm.
There's a little line going across the top, and then your forward and reflected couplers basically are at the bottom. Now we've been using this same coupler in the 10 kilowatt for for years. We
Yep.
just added the sample into this coupler to be able to provide a sample for the 3 kilowatt. And in fact, it's actually populated in the 10 kilowatt, except for we just don't connect the cable to the output of it. So
Understood. Okay. And now let's talk about the web interface. We don't use Flash, and we never have.
we don't use Flash, and we never have. Basically, from the very get-go, the way the STX was set up, it was basic HTML, and that's what I'll start off with showing you when I show you that is a basic HTML page. So as far as any browser support, we should have total browser support on our units. What we use is a graphic interface that would actually even work on IE 8, although I don't know that anybody should be running an Internet Explorer
A
8
rope
still,
start browser.
but it would work on there.
Sure.
And then all the SNMP is level 3 control security. So if you don't like our interface, you redesign interfaces for that, or if you have a large network, you could design a network of SNMPs to tell you what's going on with the transmitter. Now, one of the things with the GUI screen is all the graphics are scalable vector graphics. Scalable vector graphics basically allow you to resize any text or any graphic, and it'll look the same regardless of how small or how big it gets. It doesn't get the fuzzy edges like a picture would. So and they're usually pretty fast to draw. So
so you can get moving dynamic images.
Right. Now I am in the process of working on upgrading some of the stuff to HTML5, which would allow us to take advantage of more of the HTML5 stuff on our basic web page, and pretty much would allow you to reconfigure the screen how you wish. But
that's great.
That may not come out until this fall.
I noticed, my friend, that we're getting a lot of questions, so we're going to have to fly through this live demonstration of the user interface. I'm giving you control now, so people are going to be able to see your screen, and we can see the user interface that you've got on a 3 kilowatt there live. And there it is. I am seeing it.
All right.
Okay.
All right. Basically, this is the current screen, and this is what we have for all of our STX generation screens. What you're looking at is the main screen. Let's see my mouse here. Okay, so we're looking at his main screen. Transmitter on and off button is always ask for permission to turn it on, and this is actually a live transmitter out on the test pad. Right now, I don't have any audio hooked to it, but it's pretty basic. It's set up like this, and this is what I plan on doing. But we're logged in now, and most of the buttons are lit up, and if you hover over them, they'll tell you what we can set it up for. It allows you basic control. The status, the PA status screen is pretty simple.
This is a pretty simple unit, just 4 modules and.
Yes, yeah. So there's not a lot to that. So we'll head back here to the main screen. As we said, there's RTDS or RDS set up that will allow you to do that. And then also we got frequency shift keying. If you need to know where the SNMP MIB file is, you can right-click that or right-click that and save that file. It just show up as text. So basically it's just text. If we switch over to, can you see that?
The graphical interface, you betcha.
Okay, if we switch over to the graphical interface, this is what the graphical interface setup on this looks like. Basically any of these, if I click on any of the picture diagram, it'll take me to a specific point. I could go to, say, the audio setup, and you can see the program service scrolling. If it turned FSK on, it's going to give me a frequency shift keying at top of the hour. For each of those, I could set my gain. If I wanted to adjust any preset power or anything on a transmitter, I can click it. If I want to look at the power amplifier, I've expanded the screen to be able to look at a graphic representation of the power amplifier. We can look at to see actually the actual reading of what it is reading on each of these. Reflected power, if you click on the meter itself, you can switch from reflected power in watts to VSWR. We have a log screen, kind of trying to go through this fast, sorry.
Sure, no, you're doing great.
Because you said we got a lot of questions, so.
Yeah.
So the log will keep a log of everything. If we go to preset power, it says we went to preset power. We could actually, if we go to the PA screen, we can see the power start to come
Fall down to the preset level. Yeah.
Yeah, and we could also see it down here.
Yeah.
To where we have the preset power level too. Let's see. Exciter screen, basically it's going to highlight whatever, but the way we set up the graphical interface is so that if you could control something, it's going to give you a hand. If you can't access that, it will give you a stop sign or don't not enter this field.
And that may have to do with your level of security enabled at that point in time.
Correct. And like I say, you can set up audio delay. We can go all the way up to 43.7078 microseconds, and adjust down to 5.3
milliseconds in that case.
Milliseconds, yeah. And adjust down to 5.3 microseconds.
Okay. And on the far left of the screen over here, you can set up your primary and your secondary audio. So what happens is you set up your primary is what you're normally using. And if that should fail, you've got a backup audio path that you can set up on the left.
That is correct. You can set your silence timeout on any of these. If for some reason that silence timeout goes, it will automatically switch to your secondary path.
Excellent. That helps a lot of people. You betcha. Okay. Well, why don't we head over to the questions, because I believe there's quite a few of them here. And then some of these have been answered, but we'll read them. Is a dust filter built into the front panel? The answer is yes. And not only that, but it's washable and reusable, which is nice.
Right.
And you can change it even while the transmitter's on. And similarly, is there a filter behind the front panel? Absolutely. Where does the X-Gen go? Question mark. In this design at the moment, it's external, right?
That's correct.
But in the future, we'll talk about that.
Correct.
What is the length and depth of the transmitter? We're going to get to that in a second. I'm going to switch back over to me as the presenter, if that's okay. And I'm going to go to the next screen because that one has got the specs, and that will answer that question for our friend. And you should be able to see now the specifications. Are you seeing the specifications?
I see them.
Okay, so everybody's there. All right, so right now you can see that the depth of the unit is, where is it?
28.33.
And a third, yeah. Okay, excellent. Does the intake airflow also over the exciter side of the box? In other words, are there holes in that fence so that the air will also pass over the exciter?
There are holes that if we do the top view down, again, if you looked at that, there's a row of holes that allow a little bit of airflow that goes across the exciter as well. So it is filtered air that will go across the exciter to keep it cool. So we keep that. So we're actually cooling the whole box, even though it's divided. We are allowing airflow through the whole box from front to back.
Yep. Can the RDS use data from Arctic Palm center stage data management?
Probably could, as long as you could send it to an IP port.
Yeah.
you should be able to do that.
As long as the formatting is the same as what TR&E would do.
Correct.
Yep.
Correct.
For HD and DRM, is there pre-correction to deal with downline nonlinearities, filters, and combiners? I will answer that. That's not yet. Watch this space. Is that fair?
I agree.
Okay. What load do you use for the combiner?
The combiners inside
The reject
there,
load. Yeah.
the reject loads are actually 250 watt low, actually 500 watt loads. Sorry.
Okay, so it's a small load that's mounted to
Right.
a heat sink.
Correct.
Okay. All right. How many presets are there?
As far as the transmitter goes, there's basically one preset that you could change as far as the preset power. There's one automatic power control for the full power. If you hit preset, you only have one. Now,
Right.
if that's something that we get enough demand for, that's something that we'll add and we'll change different presets for.
Sure. Sure.
In the US, it's not very common that we do that, but I know, around the world that they do change power at different times of day.
Sure. Does it switch back to primary audio when it comes back?
It will switch back to primary audio when it comes back.
Excellent. Okay. Well, let's look at these specifications and see if there's anything we'd like to comment on here as we speak. One of the things that jumps out at me is the operating temperature -10 to 50 C. Typically, other manufacturers are only from 0 to 50 C, which isn't a big deal in a lot of the world, but there are places where it does routinely get below -10, and you wouldn't necessarily meet specs in that situation.
Right. We realize that we always try to do a little bit more, because we don't know where these units are going to be. The more
Yep.
portable they are, the more likely they're up high on a mountaintop where it's not really that friendly for humans to be, but we
Yep.
want them to be able to work and to be able to communicate effectively in those extreme temperatures. So therefore, we always look to make sure that the components and things that we're using will allow us to go below 32 degrees
Sure.
Fahrenheit or 0 degrees Celsius.
Now, the other one that comes out is the 200 to 264 AC voltage range, and that's certainly true for the full power range of 750 watts to 3,300 watts.
Yeah.
However, I happen to know that this transmitter, if you are in an absolute dire situation and you need to get on the air and all you got to play with is 110 volts, it'll work. You're just not going to get 3,300 watts out of it.
Yeah, well, without checking, I would say you at least be able to get a 1 kilowatt out at 110 volts.
Yep, and most people,
the unit will work without a problem.
Most people driving around a coverage area would have a hard time distinguishing the difference because of the inverse square law between 1 kilowatt and 3 kilowatts.
Right, and the only limitation there is because if you're running that low, the power supplies themselves have a switching over that they just can't handle that amount of power current dissipation.
Exactly. Okay, and so to summarize, the STXe-3 is the latest in a long line of reliable, efficient, performance-leading FM transmitters from Broadcast Electronics. The Elanos Group has 90 years of corporate experience and 60,000 installations and some exciting new products for all radio stations, and we're here to be of assistance. You can contact your BE representative to find out how cost-effective the STXe-3 can be, and you can register for our all totally new schedule of upcoming free webinars. This is the first of 6 in a row, happening every 2 weeks from today at www.elanosgroup.com/webinar. And we've answered the questions that we had. So we know how much valuable your time is, and we're honored that you chose to spend some time with us. And there's Stuart Peters' email address, my email address, and you can register for our schedule of upcoming free webinars at that web page at the bottom of the page. Stuart, thank you so much. This has been a real pleasure, and I've learned a lot.
Okay, thank you, Chuck. It's always nice to be able to talk about new products and what's going on, and I appreciate everybody taking the time to find out a little bit more about the STXe3 today. So
very good. And we will have if you didn't get a chance to watch the beginning of the webinar, for instance, we will record, this has been recorded, and we will put that up on the web page, the same web page you registered at, either later today or first thing tomorrow. Thanks very much, everybody, and have a very, very good day. Bye-bye.